In this chapter, we want to be able to say that I can identify and name polygons, and also I can find perimeters, circumference, and area of two-dimensional figures. So we're taking the whole idea of lines, line segments, angles, and we're starting to mesh them together to get polygons. So let's get a working definition for what a polygon is. A polygon is a closed figure. It is closed. And it's closed and a closed figure formed by a finite number of coplanar. Remember, coplanar means they all lie on the same plane. Coplanar segments, which we call sides. So these segments are going to be called sides, such that two things happen. The sides that have a common endpoint are non-collinear, and also each side intersects exactly two other sides, but only at their endpoints. The vertex of each angle is what we call vertex. This doesn't change. It's a vertex of the polygon. A polygon is named by the letters of its vertices within order of consecutive vertices. Okay, well, that's a lot of words. Let's actually put some pictures to this. So putting some pictures of this, here's what a polygon could look like. We are going to have line segments. And with these line segments, we are going to connect them at their endpoints. So right here, we are going to connect, let's put 4 lines down. This right here is a polygon. It has 4 sides. It has 4 vertices. That's where the endpoints connect. An example of a non-polygon could be a circle. A circle is not line segments connected together at endpoints. We could also have this. We could have line segments. And if it's not closed, then it's not a polygon. So that second one that I drew is not a polygon because it's open. There's a spot that is not closed. Closed means that all the sides are connected at vertices. Okay, so an example of polygon, they have to all be connected at a vertice, which is at the endpoint of the line segments, and they cannot be round shapes. So we cannot have something like this. We cannot have a shape that has 2 line segments and then all of a sudden a curved line. We cannot have that. So we have an example of polygon, closed shape with vertices at each endpoint. Then non-polygon is, of course, anything else that's not closed and circular stuff. Concave versus convex. We are going to be looking at what it means to be concave and what it means to be convex. Concave means that if we take a polygon, let's just draw out a polygon here. And if we extend the line segments, let's just extend this and put arrows on it. Extend that line segment, extend this line segment. If we extend the line segments, then these line segments are not going to end up going through the figure. It's not going to intersect the figure. That's what it means to be convex. I put this in the wrong spot. Let me put this in the correct spot. Concave. So concave means that the lines are going to end up passing through the shape. Convex means that they are not. So make sure that you put it in the correct region. So convex, if we extend the lines, they are not going to re-enter the shape. Let me show you an example of a polygon that is concave. So if we have this shape right here, let's put some lines on here. So this right here, let's extend these lines. Well, line segments. Extend the line segments. Extend the line segments. So far, so good. We have not entered into our shape again. But wait, with this line segment here, notice it goes through this shape. also with this line segment. So concave, if we extend the line segments, it's going to send a line through our figure. Convex means that if we extend the line segments, it will not go through our figure. So that's the difference between concave and convex. Equilateral polygon versus equiangular versus regular polygons. So we're going to actually get into some naming stuff. Equilateral, the equal means that stuff is equal. Lateral means that we are talking about the lengths. So all segments or all sides are congruent. Equilateral means that all the sides are congruent. All the sides are the same in length. Equiangular, the equal means that they are going to be equal. The angular means that the angles are going to be all the same. So all angles are congruent. And a regular polygon means that all sides and all angles are congruent. So equilateral, all sides are congruent. They all have the same length. Equiangular, all angles have the same measure. And regular polygon means that all the sides and all the angles are the same. They're all congruent. And the way we name a polygon, it does not matter if it's regular or not. If it has 3 sides, it's a triangle. If it has 4 sides, we consider that a quadrilateral. If it has 5 sides, that's pentagon. If it has 6 sides, we always consider it a hexagon. Now, it could be a regular hexagon. It may not be a regular hexagon. It could be equilateral. It could be equiangular. But 6 sides means it's a hexagon. 7 sides, it's a heptagon. By the way, you may be noticing that after 5, we have gone. All of these end with gone. That is because the first part comes from Greek. Penta means 5. Hexa means 6. Hepta is 7. Octa is 8. This comes from our Greek words, which a lot of math comes from the Greeks. So that kind of gets into the naming scheme of things. So let's actually get through some naming. Name each polygon by its number of sides, then classify it as convex or concave, and also classify it as a regular or irregular shape. So this one right here, let's go ahead and start off naming how many sides we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 sides. 10 sides means that this is a decagon. Deca meaning 10. So decagon. So that's naming the number of sides. Convex or concave. Well, let's extend some of the sides. If we extend this side, we're good. If we extend this side, we're good. If we extend this side, we're good, right? We keep working our way around. Wait, if we extend this side over here, this is going through the shape. So this is a concave. It's concave. And is it regular or irregular? Well, it doesn't mention anything about the lengths of the sides or the measure of the angles. So we're going to say that this is irregular. Remember, we talked about what you could assume and what you can't. You cannot assume that side lengths are the same unless if they specify. You cannot assume that angles are congruent either unless if they specify. So this is a decagon that's concave and irregular. It's not equiangular and not equilateral either because none of the angles are the same and also the side lengths are not congruent either. Part B. Well, this one right here, let's go ahead and classify how many we have. We have 1, 2, 3, 4 sides. So this is a quadrilateral. Quad meaning 4. So it's a quadrilateral. We need to say convex or concave. If we extend the sides, We're good on that side. We're good on this side. Extend this side. We're good. And we are good on all sides. So this is convex. And lastly, is it regular or irregular? Well, we know that this angle is congruent to this one. However, these two angles are not necessarily congruent to the green angles. The blue is not necessarily congruent with the green. So this would be another irregular polygon. Because not all of the angles are the same. And not all the sides are the same either. Now, if we, for example, if we would have said that this side is congruent to this side, which is also congruent to this side, which is also congruent to this side, then we can say that this is equilateral, meaning all the sides are the same. But we don't have that example, so that those are not equilateral either. Okay, part C. I don't know why D all of a sudden made it over there, but D is going to go with that one. Part C. Let's count the sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, so this is a decagon. Let's figure out if it's convex or concave. Extend some of the sides. Wait, that automatically counts it as concave because it goes through. So this is concave. This is irregular. Well, you may be wondering, why is it irregular? All the side lengths are the same. All of them are congruent. But remember, for it to be regular, all the side lengths and all the angles must be the same. Well, let me show you where some angles are not the same. This angle is congruent here. All these blue angles are the same. However, this angle out here, or the angle on the inside, that's a different angle than those blue ones. So that's why it's irregular. All the side lengths and all the angles must be the same if it is regular. Okay? This would be an example of an equilateral polygon, but not a regular polygon. And lastly, 3 sides. This is a triangle. This is convex. If we extend the sides, none of them are going to cross through the shape. And also, this is regular. Because all the sides and all the angles are the same. They're all congruent. So this is a regular shape. By the way, if it's regular, it's equilateral and also equiangular. It's both of those. So we would have to consider it as both of those as well. But for the sake of time, I'm going to not write that down. Okay, let's talk about perimeter and circumference. Perimeter is the distance around the shape. The distance around the shape. Circumference is also distance around the shape. But the difference between them is that circumference deals with circles. Perimeter deals with all the other shapes that are not round. Okay, so polygons. By the way, I did not mention, but up here, after we get past 12 sides, we start naming it by the n. So if we have 13 sides, it's a 13-gon. If it's 14 sides, it's 14-gon. If it's 20 sides, it's a 20-gon, and so on. So we just name it by whatever the number is with the sides. Going back, so perimeter is distance around a shape. Area is a space inside the shape. How much can fit inside the shape versus if I walk around this space, how far did I walk? Okay, so perimeter, you can think of it as if you were going around the yard. Let's say we had a fence and we walked all the way around our fence. How far did we walk? That's perimeter. It's a distance around an object. Area is a space within the object. So if we have, let's say, a triangle, it's a space that is inside of it. Why perimeter is a distance around. Okay, so we're going to have 4 shapes that we're going to look at with perimeter and area. we are going to say that these are going to be the notation we use. Big P is going to stand for perimeter. Big A is area. Big C is circumference. Small b is base, and so on. Okay? So if we have any triangle, and let's call this side C, let's call this side D, and let's call this side B. And let's drop its line segment here where it's 90 degrees, and let's call this H, where that is the height. Because if we want to find the area of a triangle, we have to know the height. So perimeter of the triangle is just going to be C plus B plus D. Add up all the sides. It's as simple as that. Just add up all the sides for the distance, and you have it. For area of a triangle, this is actually half of the base, half times base, times the height. You could also look at this as B times H divided by 2. Base times height divided by 2. Either way, it means the same thing. That's how you find the area of any triangle. Half base times height. How you find the perimeter of any triangle is just add up all the sides. For a square, let's call each side S. Squares, all the sides are congruent, so that's nice. Every single time, they're always congruent. So perimeter is just S plus S plus S plus S. In other words, we have 4 times S. 4 times that amount. Area is just S times S, or S squared. That is how we find area of a square. Rectangle, we're going to call this our length. We're going to call this our width. Okay, so this would be the same as that. This side would be the same as the other side. So perimeter of a rectangle is length plus width plus length plus width. In other words, we had 2 length plus 2 times the width, right? 2 times the length plus 2 times width. That's simplifying it down. For area of a rectangle, all we had to do is just go length times width. That's it. Circle, you guys have all seen this stuff before. Circle, we cannot say perimeter. Instead, we use the word circumference. It means the same thing. We're just going around the shape. So for the circle, the circumference is equal to 2 times the radius times pi. Well, let's talk about what the radius is. If we have the center of the circle to the side, this is what we call the radius. The diameter is a total length. Okay, so diameter is total length, radius is half that. So another way of thinking of circumference is just diameter times pi. If you know diameter, you're good. You can find circumference is just diameter times pi. The area, we still use area because it's this area within the shaded region, how much space we have, is going to be pi times the radius squared. So this one we do need to know what the radius is for area. But finding radius, if you have diameter, is relatively simple. So that is our equations that we're going to use. You guys have seen those before, so you should be able to be fine with what we're going to do next. Find the perimeter or circumference, because perimeter circumference depends on what shape you have, and also the area of each figure. We have a triangle. Let's find perimeter first of this triangle. All we had to do is go 12 plus 15 plus 8. Just add up all the sides. 12 plus 15 is 27. 27 plus 8 is 35. So our perimeter is 35. Just add up all the sides. For the area, the height is a 4. Okay, if this was a right angle, a right triangle, meaning if this was 90 degrees, then 8 would be the height. But it's not a right triangle. It may look like one, but it's not. So area is base times height. By the way, the base is the one that is connected with this dashed line. It's connected to the height. It's the one that the height is intersecting. Okay, so they intersect at that one point. It's the one that intersects. So 15 times 4, I'm going to write it this way, and we're going to divide that by 2. In order to find this, This would end up be 2. 2 times 15 is 30. That is our area of that shape. For the circle, this is the diameter. 6 is our diameter. Let's find the radius.
3.
Radius would be 3. We just take diameter, divide that by 2, because diameter is twice the radius. Okay, so if we want to find, we can't use perimeter, we have to use circumference because perimeter is just for our polygons. So we're going to find circumference, which is just our diameter times pi, or 2 times the radius times pi. So in other words, this would end up be 6 pi. And if we go 6 times pi, let's go ahead and find that with the calculator. Give me one moment. 6 times pi is going to be about 18.85. I personally like the one with the symbol pi because it's accurate. The minute we round something, it turns it as an estimation instead of an exact number. Okay, for area, we know the radius. The radius is 3, so we're going to go 3 squared times pi. I know I wrote in the area the formula that's pi times radius squared. Multiplication is commutative, so it doesn't matter. 3 squared is 9, so this is 9 pi. And 9 times pi is going to give us about, we're going to estimate, 28.27. So that's finding the circumference and the area of that shape.